Earth has witnessed some incredible events during its 4.54 billion years alive. But our blue marble hasn't even come close to scratching the surface of what it will see during the 110 trillion year lifetime of our solar system. So, what will actually happen? Well, in about 50,000 years, the Niagara Falls will have eroded the remaining 32 kilometers to Lake Erie and cease to exist. This was also the time when we were expected to enter another ice age. However, due to the impact of global warming, this icy era has been postponed to about 100,000 years from now. Now let's leap forward to 2 million years in the future. Here we have the estimated time for the full recovery of coral reef ecosystems. But as this part of the planet heals, another changes. In about 50 million years, the continents Africa and Europe are expected to collide, creating mountain ranges like the Himalayas and completely wiping out the Mediterranean Sea. And in 100 million years, Earth will likely have been hit with an asteroid comparable to the one from 66 million years ago that wiped out the dinosaurs. But this is just the beginning. What happens when the sun starts to change? Fast forward to 1 billion years, the sun's luminosity is increased by 10%, causing Earth's surface temperatures to soar to an average of around 47 degrees Celsius. The oceans evaporate and the water vapor is lost to space. Life as we know it struggles to survive. During this period, Earth's day also extends to 27.3 hours based on the moon's continued recession of about 2 centimeters per year. The distant reservoirs of comets, the Kuiper Belt and Oort cloud, will be disturbed as nearby stars pass close to the sun in about 1.4 billion years. This could send a shower of comets into the inner solar system, potentially leading to impacts on the remaining planets. In 1.5 billion years, the surface temperature of Mars may warm up enough to reach the same temperatures as the last ice age, which would be around 10 to 11 degrees Celsius, potentially making it a more suitable home for life as we know it. 2 billion years into the future, Earth's outer core freezes, causing its magnetic field to disappear. Without this protective shield, the solar winds deplete the atmosphere, causing Earth's temperature to rise even further. And by 2.8 billion years, with a surface temperature of 149 degrees Celsius, the last prokaryote would die, meaning the end of life on Earth. In 3.5 billion years, the sun will be 40% brighter than it is today, increasing its temperature to around 6,000 degrees Celsius. In 4 billion years, our entire galaxy undergoes a dramatic transformation. This galaxy will collide with ours and will begin the process of merging together to form one united galaxy. By 5.4 billion years, the sun exhausts its supply of hydrogen and helium in its core and expands into a red giant, engulfing Mercury, Venus, and possibly Earth. Even if Earth escapes being engulfed, the intense heat from the sun scorches our planet. At 7.59 billion years, the sun reaches its maximum size as a red giant, having lost 33% of its mass. At this point, the outer gas giants will now be in the habitable zone. These planets will be less affected by the sun's transformation, but the increased solar radiation will alter their atmospheres. The moons of these planets could have their icy surfaces melted, potentially creating environments that could support life, at least for a time. For example, Europa, a moon of Jupiter, is thought to have a subsurface ocean of liquid water. This ocean is thought to be heated by tidal forces from Jupiter, and it may contain the ingredients for life, such as oxygen, hydrogen, and carbon. Or a moon of Saturn named Titan, which has a thick atmosphere and could achieve surface temperatures warm enough to support life. At around 8 billion years, the sun will then shed its outer layers and leave behind a white dwarf, marking the end of the sun as a main sequence star, and all potential life in our solar system will most likely die. Now, Pluto and other dwarf planets will remain largely unaffected by the sun's red giant phase. However, as the sun dims and cools in its white dwarf phase, these objects will become dark and frozen realms, even more so than they are now. By 100 billion years, the only galaxies visible from our solar system will be those that are gravitationally bound to our local group, which is over 54 galaxies out of the trillions that we can see now. Now fast forward to about 1 trillion years. The white dwarf sun will finally cool to become a black dwarf. Then over the course of trillions of years, when a nearby star passes so close to the remaining planets, they undergo major instability and give them enough gravitational energy to escape the sun and never come back. And finally, in 110 trillion years, the sun, which is now a black dwarf, cools and dims, eventually fading away, marking the end of the solar system as we know it. But on the positive side, if 110 trillion years represents a whole year, humans have only existed for less than a tenth of a second. So I guess you can say we still have some time.